Hello, everyone. Welcome to my presentation. My name is Amara Ubnak. I'm PhD research scholar from uh, Ethiopia. Currently, I'm studying my PhD in IIT Bombay Department of Design under supervision of Dr. Sagata Karmaka. So the presentation title is on research design for simplifying anthropometric data collection process using PCA and regression analysis. This research design is not only used for the simplifying anthropometric data collection process, but also it can be used for other applications. We'll see on the recommended section on the last. So the presentation outline covers actually six sections: the exploration of the study, objective of the study, research method, result, conclusion, and at the last we'll see the recommendation or suggestion. So when you to explore our study, design of any facility for the target user may require large sets of variables, but conducting all those variables maybe it is quite tedious, time consuming and costly, and it also needs a special support. So in physical measurement, due to this fact, we need to reduce the numbers of physical anthropometry, or they have to identify those key variables which represents the rest of that large number of required variables. So this can be achieved by PCA following with regression analysis in order to simplifying or identifying our key variables. So the current study actually it aims to demonstrate how to reduce the numbers of variables using PCA when the large numbers of variables are involved. Okay. So in this research method, to identify those key variables, we used the two analysis methods. We have the PCA analysis and as well as regression analysis. So in PCA analysis, first, all the measured variables should be clustered according to in closely related sets. So in factor-wise category. So after we clustering those variables in each factor, we have to identify the predictors. That means the one having higher factor loading coefficient that represents the rest of closely related variables should be identified to include in a minimum data set, and also to identify those less commonal variables. Less commonal variables means the variables having less commonality also should be included on the minimum data set. That means as a key variable we have to include rather than dropping. And also in regression analysis, we have it's used for the linear regression equation formulation. That means it can estimate the closely related variable as a functions of their predictors. So you use this regression analysis for this, and as well as also the analysis of the correlation coefficient. This correlation coefficient also important to reject or to drop or to include in our minimum data set by this the relation coefficients. That means the one which is having less correlated coefficient should be included also in a minimum data set, because they are, since they are not represented by their predictors due to having less correlation coefficient, we have to also include it in a minimum data set. So we'll see on the result actually. So to identify those having the variables having factor loading coefficient greater than 60% and commonality in correlation coefficient having greater than 70%, were all considered to be high intercorrelated variables, or they are closely related variables in each their factor loading category. So if they satisfy this condition, we dropped them, and if they are not satisfying this condition in each category, we have to include a minimum data set. So for this research design, we measured 32 anthropometric variables from 250 male participants from Ethiopian army personnel So before you go to the PCA analysis, we have to test whether our data, collected data, are normal, and also majority of the variables also should be also significant in their significantist variation. So in our case, majority of the variables, actually more than 80%, they are normal, and they are also they have significant variation also high. For conducting or analyzing this PCA and as well as regression analysis, we use the statistical tool. We call it the SPSS statistical tool we use. So all 32 variables are here categorized, actually measured first for both male and female, but we only took for male for PCA analysis because majority of the variables, the collected data are normal in male, but in female they are not less normal. So due to their less numbers of sample size we have, so we are not we only include in our PCA analysis for male. Okay, so all the 32 variables are categorized in 6 factors. After categorizing in 6 factors, variables having higher factor loading coefficient should be taken for in a minimum data set. That variable is called predictors. Those predictors can represent their the closely related variable, but all this. So we took 6 variables or predictors from 6 factors, but all these variables may not represent all the 32 variables. If you see pupil height and pupil length, even though they have higher factor loading coefficient, their commonality is less. That means it is less than 0.7. So we included in a minimum data set since they are not represented by their correlation. I mean, their predictor due to less commonality. Mass also should be included, even though it is closely related by its predictor. We cannot represent by its predictor. Mass always should be measured whenever measurement is required. So total 9 we have here. In the regression equation, we estimate the closely related variable as functions of their predictors. So 24 variables are here predicted as a function of their predictor. But if you see 13, 14, and 21, their regression equation is cancelled. Why? Because their correlation coefficient is less. So due to this, instead of representing these variables by their predictor or estimated by their predictor, we have to include a minimum data set. That is foot predicts, hand predicts, and as well as the airborne rest height should be included a minimum data set. So total T1 variables are identified. If you see here in V1 is a predictors, V2 is variables having less correlation coefficient, V3 is variables having less commonality, and V4 is the mass, which is a targeted variable. So in conclusion, we have 12 sub variables account for 32 anthropometric variables can be identified when the measurement survey of large sample size is required. So these only 12 dimensions can be measured actually to estimate 20 dimensions using the sample size having greater than 250 sample size. When involved during this, we have to measure the 12 measurements. Okay. So this application can be used also for the other population, also not only for Ethiopian Army, also in population. So in recommendation, I need your actually attention here. It's very important for researchers and real application also. This 12 variables not only used for simplifying data collection, but also anthropometric data analysis also it can be used because the closely related variables have similar characteristics. So instead of conducting the whole variables to analyze, because it is time taking and tedious and difficult, not only the way of reporting also may be difficult. So instead of taking all the 32 variables for data analysis, 12 may be enough. So in my other, publication, my paper, I used this application actually. So for analysis of variance, for significant tests, something like that. So this 12 variable may be enough. For physical ergonomic evaluation also, the 12 persons who represent exactly these 12 variable measurements can enough for physical ergonomic evaluation. For example, after we have made our product or the workspace, we may test the accommodation of that space by the real human. So at this time, this 12% may be enough for this purpose. If you have any question later on, we will see later on. So thank you very much for your attention. So I finished here. Thank you.